Let S be this set containing first 6 natural numbers. Then find the probability that a randomly selected onto function means codomain is same as range. So find the probability that a randomly selected onto function g from S to S satisfies this equation, that g of 3, this is twice of g of 1. Now in this problem we have to first find the total number of onto function from S to S. That will give us number of elements in sample space. And then we have to find that how many functions are there which are satisfying this condition, that g of 3, this is twice of g of 1. And then probability will be number of favorable cases by total number of cases. So the given set, here the function is defined from S to S. That means domain is S and codomain, that is also S. Right, so first set is S. In this set we have elements like 1, 2, 3, 4, 5 and 6. These are the 6 elements in first set. And the second set is also same set. Right, second set is also S. The function is defined from S to S. And in the codomain is also same set. In codomain we have these 6 elements. Now remember, whenever number of elements in two sets are equal, right? First set, whenever the number of elements in domain and codomain is equal, then a function is onto function when it is 1 function, right? Number of 1 function will be same as number of onto function, right? So because once you make function many one, then you cannot make it onto. Onto means codomain is same as range. The meaning of this word onto function will be that codomain and range, these two are equal. So in codomain, we have 6 elements, 1, 2, 3 up to 6. And in range, you cannot have more than 6 elements, right? Range will be f of 1, f of 2 and so on. And function means for each element, we can have only one image, right? For any one element of set A, there will be only one value of f of 1, f of 2 and so on. So if two sets have equal number of elements, then number of onto function, this is same as number of 1 function. So here if we talk about number of elements in sample space, this will be number of 1 function from set S to S. And that will be nothing but 6 factorial, because for this first element 1, we have 6 options. Right? For this element 1, we can connect either with 1 or 2 or 3, any one of these 6 elements. Let us say f of 1 is 2. Now for 2 we have only 5 options, right? Because we have to make function 1, 1. So for the next element 2 we have only 5 options. Either it will be 1 or 3 or 4 up to 6. Let us say if f of 2 is 6. Then for f of 3 we have only 4 options and so on. So number of functions, this will be 6 into 5, number of 1 function, which is same as number of onto function when we have equal number of elements in two sets. So this will be 6 into 5 into 4 up to 1. So that is 6 factorial. Now let us try to figure out that how many favorable cases are there, right? If we find a number of favorable cases, so then we can get the probability that a randomly selected function will satisfy this equation, that z of 3, this is twice of z of 1. So favorable cases are all those cases where uh, we have this condition satisfied, that z of 3, this is twice of z of 1. Now the same relation you can write in this form, that z of 1, this should be half of z of 3, right? Now let us figure out that how many different possibilities are there for z of 3. Now because z of 1 has to be half of z of 3 and all of these are integers only, so z of 1 will be integer. So from there we can conclude that z of 3, this must be even number, because if z of 3 is an odd number, then z of 1 will become fraction and we do not have fractional numbers here. So for z of 3, we can take only those values which are integer, which are even integer. So for example, if I calculate z of 3, you can take z of 3 either as 2 or you can take 4 or you can take 6. But you cannot take z of 3 as 1, because then z of 1 will become 1 by 2. We cannot take z of 3 as 3, because then z of 1 will be 3 by 2, right? So for connecting this element 3, we have 3 options. Let us say E is the event that a randomly selected function is satisfying this condition. G of 3 is twice of g of 1. So number of elements in E, or the number of onto functions satisfying this condition will be, for 3 we have 2 options. Either you can select 2 or you can select 4 or 6. Right? Z of 3 will be either 2 or 4 or 6. We cannot have odd values for Z of 3. So for Z of 3, 3 options. Now, once you decide Z of 3, Z of 1 has to be half of that. So for Z of 1, there is only one option. Let us say in this example, suppose if Z of 3 was 2, then Z of 1, this must be half of 2, which will be 1. So Z of 1 has to be 1. And for remaining 4 elements, there is no restriction, right? So for 3, we have 3 options, either 2 or 4 or 6. For 1, there is only one option. Once you decide Z of 3, Z of 1 is half of that. And then for remaining 4 elements, we have 4 options. For this element 2, we have 4 options. For 4, we have 3 options, and so on. So these are the number of favorable cases, or the number of matrix, or the number of functions satisfying this condition, right? So because for these remaining elements, for example, 2, there are 4 options. You can connect with any one of the remaining 4. Then for 4, we have only 3 options, right? And similarly, for 5, we have only 2 options. Either it will be 4 or 5. And similarly, for last one, we have only one option. So for the remaining 4 elements, we have 4 factorial number of options of connecting with the second set, right? So number of onto functions satisfying this condition, this will be 3 into 4 factorial. Now the question is, what is the probability that a randomly selected function will satisfy this condition? So these are the number of favorable cases, 3 into 4 factorial, and total number of onto function, this is 6 factorial. So probability will be 3 into 4 factorial by 6 factorial. 4 factorial you can cancel, and then you have 3 and 6 and 5. So 1 by 5 into 2, that will be 10. So this will be the required probability, right? 1 by 10 is first option, and therefore that should be the correct answer. So this was a problem from functions as well as probability. First of all, onto function means codomain is same as range. And if two sets have equal number of elements, then number of onto function is same as number of one function. So here number of elements in sample space, this will be 6 factorial. And favorable cases means those onto function which are satisfying this condition, that Z of 1 is half of Z of 3. So for Z of 3, we had only 3 even options, either 2 or 4 or 6. For Z of 1, only one option. And for remaining 4 elements, 4 factorial. And therefore, probability will be number of favorable cases by total number of cases. Finally, we got 1 by 10. And that is the correct answer for this problem.